Okay, so from the first lecture this morning, we looked at essentially what a fractal is, some examples of generating fractals. We did make a start on this, so I'm just going to recap this from this morning because it is quite important. It is on assignment, so assignment 10. So after this session, you'll be able to crack on with assignment 10 and finish them all if you want. Okay, so the midpoint displacement algorithm, this is essentially one way in which we can randomly generate a landscape. Okay, so essentially what you do is if y is a coordinate in terms of the height, yi plus a half essentially means that's the midpoint between the value yi and yi plus 1. So if you imagine that yi is the height coordinate of one point, and yi plus 1 is the height coordinate at the other end of the line, calculated by just a half times the sum of those. So we calculate the midpoint, and then we displace it in the vertical direction by a random amount r. Now this random amount r falls within the range r min to r max. And that range is important because what we do is for each iteration we reduce the values that r can take by reducing that range. Okay, so a simple way would just be halving it. So if we start off, for example, r min is 1 and r max is 1, we halve each time. The next time we're between a half, minus a half and a half. Next time we're minus a quarter and a quarter, etc. And so this is what happens. We start off with a line. So on the first, imagine that's your yi, and that point is your yi plus 1. Yi plus a half would be about there. So we calculate that point and randomly move it up or down. And then that gives us two lines. So now we have two midpoints. Calculate those, randomly move them up and down, and we keep going. Okay, so actually at this point I'm going to get you to have a go at one. So I'm going to hand out another one of my activities, try not to step on anyone's toes. Yeah, it's like it. Yeah, it's no one's fault. Agreed. No one to blame.
Going in the wrong direction.
Has any of you got any money? I mean a coin.
Yeah.
Because we need a random up or down. There it is. You looked at me funny when I said you got money. That's what I got. 2p to my name, that's it. Oh, if you've got some of what, essentially, if you've got some way of determining a random, one of two random things. Yeah. If you want to throw your iPad up and
I can download
there's some language in my ear. You hear that? Flipping coin. Right. Okay, so what we have here is a grid. Oh, sorry, I thought you were throwing out. Right, we have a grid in. I don't know whether it's come out very well on the printing, but I've already done the first one. I've moved the first midpoint, which is at 16. I've moved it up to 24. The reason I've done that is I want it to look like a mountain, because that could have gone down and then it would look like a valley. Okay. Right, so what we have is we have a point there and a point there. Okay, so that's my yi, that's my yi plus 1. So I'll have a midpoint halfway between 2, which is at 16, and I've moved it up so it's equal to 24. Does anybody know why I chose 24?
You wanted to.
Yeah, I did want to, yeah.
Is that 24 in question?
Do you know why? One of the reasons why we do time in 24s and 12s.
360 cuts down into lots of numbers.
Yeah, exactly. It divides down very easily. Well done. Okay, so what I'm going to do now, right? This first up or down bit is 24. What I'm going to do is I'm going to toss a coin, and if it's heads, I'm going to go up. If it's tails, I'm going to go down. And mine's tails. So for the first midpoint, what I'm going to do is I'm going to calculate the midpoint, and I'm going to move it up or down by 6. Okay. I'm not going to move it up or down by 12, so that'll be too much. I'm going to move it up or down by 6. The next time I do it, I'm going to move it up and down by 3. Next time I do it, I'm going to move it up and down by 1.5. So I'm halving the amount I'm moving it up and down by. So this one was tails. So what I do is I calculate the midpoint, which is there, and I'm going to move it down by 6. So I get a point there. That makes sense? So I did have this line. Okay, I had that line. I calculated the midpoint, which is there. I tossed a coin. Mine was tails, so I moved it down by 6. Midpoint, which is at 24, which is there. I'm going to toss a coin again. Tail. I'll toss a coin again. It's heads. What are the odds of that, by the way? 3 coin tosses, tails. 3 tails. Yeah, 1 in 8. Yeah. Okay, so I'm going to move it up. I wanted to move it up anyway. If I move it down, it'll be a bit too spiky. What have I got? I've got 12 plus 6 is 18. By the way, you should be doing your own one.
Are you not copying yours?
You should be flipping a coin. Got to be careful with the terminology with using a coin, haven't you? Use your imagination. Right. Okay, so what I have now is I've got 4 edges here. Okay, so my midpoint for this one will be at 4, and I've just flipped a coin and it's come up with heads. So what I'm going to do is I'm going to calculate the midpoint, which very easily using a ruler. Okay, it's going to be there. Then I'm going to move that point, which is 3, up by 3. So I'm going to go to there. You see what I'm doing there? So I had an edge between those two. Find a midpoint. I tossed the coin. And then it went up. Okay. I've got another edge here. Find a midpoint, which is that point there. I don't know if you can see that. I'm going to toss the coin again. And it's heads. So that's going to get moved up by 3. So 15 plus 3 is 18, so it's going to be there. I've got an edge here, which the midpoint is there, which is at 21. That's heads. That's 3 heads in a row now. Move that up by 3, I'm going to get one there. And I've got a midpoint here. So my midpoint here is at 9. And it's 4 heads in a row. Coin is yeah.
It's the US election.
The Russians have got to this coin. Right. Right. So do you all sort of understand what I'm doing here?
No.
Yeah.
Oh, really?
How many times you do it?
Manage it. Yeah.
So basically, like when you go halfway, then you go halfway between that halfway, and then just keep on like getting smaller and smaller.
Take this one. That was my midpoint. I tossed a coin. It went head, so I'm going to go up, and I got it by 3.
But where's that halfway between?
That is halfway between those two.
So,
Alright.
okay, is it meant to go to 4 or not then?
Sorry.
Were we meant to go to 4 then?
Which one's the 4?
But X is 4. Because
Yeah, because the midpoint there was at
these two.
that point there.
Yeah.
I should have done different colours.
Like this.
Oh shit.
So did you flip a coin for that?
Yeah. Every time you calculate a midpoint, flip a coin. If its heads go up, if its tails go down.
You've gone up by 6 rather than 3.
Yeah,
He's gone up by 3 rather than
you know how you've done the midpoint, and you've done, is it like midpoint to midpoint?
Yeah.
So
So this one, I'll be finding between those two. That one will be one there, move up and down. There'll be one between that one. There'll be one here.
it's just find the
Yeah. What I probably should have done is actually drawn that edge and then moved it up. But what happens? It gets really complicated. You get lines on it, so I'm just doing it dots at the
and
time.
then you,
Okay, so I'm going to carry on flipping.
Are you going to draw lines?
Yes.
But how do you know when to draw? Well, like.
Wait to
what-
stop.
No. Well, yes, but where?
I'm going to draw a lot. I'm going to join the
Dot to
dots.
dot, but what
Join the
dots to
dots.
what dots?
Just a second. So if I was to stop here, I draw that the line there, up there, up there.
oh, so you join all the midpoints.
Yeah.
Oh.
All the dots I've got. Yeah.
Okay.
And I'll stop when I get bored. So I just flipped a coin. That's heads. So halfway between these two is there, and I'm going to go up by 1.5. So I'm halving. The first went up and down by 6, then I went up and down by 3, then I went up and down by 1.5.
Wait, are you going midpoint by the 8 axis?
Yes.
Oh, no, 8.
Yeah, exactly. So halfway between 0 and 4 is 2. So halfway between those two is just going to be that point there.
Yeah.
So if I flip a coin,
So how do you define how much you're going up by? You've gone up by.
it was 6. Iteration 1 was 6. Iteration 2 was 3. Iteration 3.
How come you run up 6, 3, and 1.1?
I just halved each time.
Oh, right.
So that's my range.
Oh, right.
So I've deliberately done it like that. So it doesn't go too jagged.
Oh, right. Okay.
The first one went up by 24. If on the second midpoint I went up by 12, it would be either up to there or down to
Oh, yeah.
there. So this one, I flipped a coin, it's come at tails, so I'm going to go down by 1.5.
That's not so.
This one here, there's the midpoint at 12.
That's not so.
Flip a coin, it's tails, so I'm going to go down by 1.5. Sorry?
The Rockstar games usually.
Similar, yeah. You'll see it later. Tails again. This coin is rigged. Okay, I'm not trusting this coin ever. Heads. Okay, this is an interesting one. I just go off the top. Okay. So what I'm doing is I'm splitting it, finding the midpoint.
Oh, and each time you divide it by 2 as
Yes.
to the distance, like.
To get the
like what
midpoint.
you do.
And then you move it up and down. Yeah.
By half of what you're doing.
Tails again.
So the mountain's got like a new peak now.
Yes. So I've actually gone above the original. And that last one was heads. So that's about there. Okay, I'm going to stop there because I want to. Okay, what I'm going to do now is just draw a line between all my points. And this is my mountain.
Oh, yeah.
You don't have to embellish your mountain with any form of artwork. Fine. So I'm meant to be a goat. Yeah.
It's after the pen.
Okay, so it is essentially a midpoint displacement algorithm. Find the midpoint, displace it. It's nice when the algorithms are actually named, so that's what they are. Notice that's random. So how many coin flips did we do? So we got. I went up to 3 iterations. So how many coin toss flips would there have been? So iteration 1 there would have been 2, 4, 8. So in total I did 14. If I did 14 coin tosses, each coin toss has got 2 outcomes. 2 to the power. No, that's probably right. Just trying to work out how many different mountains we can get. There's a lot.
2 to the power 14.
Yeah, I was thinking that's far too high, isn't it? It must make sense. But yeah. In other words, if we were to do it, there's a very slim likelihood we each get the same mountain.
Yeah.
It's totally random.
What software did you use to make it?
Usually C.
C.
C. Have you ever heard of C?
Like SEE or
No, C, as in the letter C. You could use Python as well. C. Java. Matlab's not really the best thing to use for games because it's what we call high level. It sits on top of lots of other things. So you want something which is low level. Do you know what machine programming is? Machine assembly language. The way microchips work is we have to tell them what to do. You have a compiler language, you write in your code, and then that compiles it, and it compiles it into machine code. So yeah, if you want to start writing games, look at C. Just C, or yeah, or Python. Right, we all had fun then. Plus in the C language means increment by 1. So C++ is a more advanced. You still use C. And you've also got something called C#, which is object-oriented. So they're different flavors of the same thing. Okay, we all done it then. I regret that getting you to flip coin yourselves back. Bad mistake. Okay. On that one, I got you to halve the displacement each time. That's quite a sort of a crude one. What we can do in practice is we can set a roughness parameter, which we refer to as h, and our range is reduced by this expression there. So 2 to the power minus 2 times n times h. H is a number between about 1 and 0 and 2 or 0 and 1. N is your iteration. So for each further iteration, so as n gets higher, 2 to the power minus 2nh gets smaller and smaller and smaller. So as your iterations increase, the range of which your random number decreases. And h is referred to as a roughness parameter. So when h is 0.5, minus 2nh will just be 2 to the power minus n. Okay, so 2 times a half is 1. So that means your range is halving each time, which is similar to what we just did. If h is small, close to 0, the range will be close to 1, and the amount you displace a midpoint doesn't change that much, and you'll just end up with sort of almost random sort of jagginess. But when h is larger, i.e. 1, we have 2 to the power minus 2n, which is then we're quartering the range each time. and that tends to give a smoother landscape. Okay, so that's what the roughness parameter is. And here are three. What I've done here is I've saved whether they went up or down, and I've saved a random number, but I've just changed the roughness. So as for a small roughness, you get a jaggedy edge, a jaggedy one. For 0.5, you get some, reasonable one. And as H increases, you get smoother landscapes. So you can have some form of control over it. Even though these landscapes are random, you still got that control. Yeah, I was going to show, I might as well show you the Matlab code for that. Okay, now this is directly linked to your assignment 10. In assignment 10, I've asked you to apply the 2D version. Okay, I'm going to give you the code for the 1D version, because if I gave you the code for the 2D version, you'd all get the assignment that easy, wouldn't you? Okay, so this is my fractal mountain code. Okay, so I just talk you through this. Don't really need the top one, I'm just going to change that. Okay, define variables. What I've done here is nmax is the maximum number of iterations I'm going to. You don't need that to be very high. In the 2D case, I think I normally go to about 6. So maximum number of iteration. Roughness parameter, I'm going to start my H at 0.5. Big N, that is the total number of points in the final landscape. Okay, so, and that's related to nmax. So if you think about it, well, if n was 0, you'd have 1 point at one end of the landscape and 1 point at the other end of the landscape. When n is 1, okay, you'd have a point at one end, a point at the other, and a midpoint. So that's how many points you have is linked to 2 to the power n max plus 1. This S, this is a step between the endpoints. So what I do in the code is down here, I've defined an array of zeros 1 to n. So that's all of my zeros. But only at the final iteration will I have non-zero values in y. Because remember, we have to sort of leapfrog them. So let's just explain that in a bit better details. So let's say I'm going to 2 iterations. So 2 to the power 2 plus 1 is 5. So I have 5 points in total. On the 0 iteration, sorry, on the first iteration, I calculate that one. So that's my yi, that's my yi plus 1, and that's the midpoint. So I have a step of 4. So the step in this case would be 1, 2, 3, 4. But a half step of 4 is 2 to get me to the midpoint. That makes sense. So in my code, S is how many steps to get from yi to yi plus 1. So in this case, it's 4. And a half step is to get to the midpoint. That will make more sense when you come to do it. So my step is 2 to the power n max. Okay, so for my example just now, when I use n max as 2, step was 4. Half step HS, I just use for half step. Half, whatever S is. Okay, so we loop through the iterations, use a for loop, so n goes from 1 to n max. The range, so this is 2 to the power minus 2 times n times h. And then we loop through the edges, randomly displacing midpoints. So this for loop is slightly trickier than most for loops. Remember, this is the start number for I, this is the end number for I, and this is the increment. So starting at 1, I'm jumping S steps. Okay, so on my example just now, when I had n max is 2, okay, so this will go 1, jump 4 to n minus s. So I'd only do it once, so I 1. And the yi plus half step is the midpoint. That makes sense? So the 0.5 times yi plus s, okay, that is calculating the midpoint, a half. half times the sum of each end of the line. And then I randomly displace it up or down. Now, this is my range, so that's calculated there. But what does this 1 minus 2 times ran do? I'm just going to bring up the command window. I've got a massive stack of... Okay. Right. What? Sorry about this. I've turned it all off. I think